Yes, welcome to lesson 6 of colligative properties. We are basically discussing depression in freezing point as one of the colligative properties that we listed. And after knowing how we can make a few calculations to determine molecular mass, freezing point, to determine cryoscopic constant, here we want to look at the experimental bit. If you're told to determine molecular mass experimentally, here I want to give you the theory that we can do in the laboratory to do this experiment. So here we have the setup of the apparatus. This is called a setup of the apparatus. And what we have are tubes that are assembled with only one tube a bit unique, that it has a side arm. We have what we call the inner tube labeled here, and then we have other bigger tubes, this and this. And then apart from this that has a unique side arm for introduction of the solute, this one here could even be simply a beaker which is empty, and then we have another beaker outwards which is bigger, in which the two are inserted. For it, it has what we call a freezing mixture. Freezing mixture of ice and salt. This is going to be used to cause the cooling of or the freezing of the contents of the inner tube. And then the one in the middle is empty. And why is it empty? We want to create a vacuum to ensure that there is uniform cooling within the contents of the inner tube. And then in the inner tube, we have what we call the Beckman thermometer. And this is a special form of a thermometer that is used and can detect very small changes very small changes in temperature. Otherwise, clinical thermometers may not determine or may not detect the small changes in what? In temperature. So in the side, in the inner tube, there is also a stirrer, and even in the freezing mixture, there is also a stirrer to also ensure continuous stirring of the mixture, to ensure continuous distribution of heat throughout the mixture. And so, what is this setup of apparatus used? This setup of apparatus is simply used to determine the freezing point of the solvent, the pure solvent, and then the freezing point of a solution after introduction of a known mass of the solute. So in other words, what we do with this set of apparatus is to determine the freezing point from the thermometer of the pure solvent. Then later we determine the freezing point of the solution. So once we determine the freezing point of the solution, then we can use the knowledge of the calculations to determine the molecular mass of the non-volatile solute. So what could be the procedure that we could use here? Procedure. We are going to get a known mass of a solvent whose Kf or cryoscopic constant is known, and we introduce it in the inner tube. So we are going to say a known mass. I can even quote the mass, a known mass, maybe a grams of a solvent, of a pure solvent whose cryoscopic constant, Kf is known, is introduced introduced in the inner glass tube, and the apparatus is assembled as above. The apparatus is assembled as above. So now we have introduced a known mass, 8 grams of a solute, and the apparatus is assembled above. So after assembling this apparatus like above, then we are going to stir. So we shall say that the solvent is stirred. The solvent is stirred until we register a steady temperature at which the solvent starts to freeze. So the solvent is stirred until a steady, or sometimes we call it constant temperature, at which the solvent freezes is observed and recorded as the freezing point of the solvent, freezing point of the solvent, and that would be maybe T naught. I can put the note down, degrees Celsius. So we are saying the solvent is stirred until a steady or constant temperature at which the solvent freezes is observed and recorded as the freezing point of the what? Of the mixture. And then, of course, now it has been frozen. So it is, if it's water, it will be in ice form. If it is any other solvent, it will be in solid state. So what do? We are going to remove the inner glass tube, warm it gently to melt the solid, and then place it back in the mixture, or in the apparatus. So we are going to say that now the inner glass tube is then removed. After being removed and warmed gently. To do what? To melt. To melt the frozen solvent. Then to melt the frozen solvent. Okay? So after now melting the solvent, we now have our solvent back, and what we shall do, we shall gently add through the side arm, we shall add or introduce a known mass of the non-volatile solute whose relative molecular mass is to be determined. So we are going to say that I can now wrap this. And that now a known mass, maybe I can call this one now B grams of a non-volatile solute, whose relative molecular mass is to be determined is introduced in the inner tube or in the solvent, through the side arm, through the side arm, and stirred, and the mixture is stirred. So through the side arm and the mixture is stirred to form the mixture is stirred to form a solution. Full stop. So now we no longer have a solvent, now we have a solution. We have introduced the non-volatile solute through the side arm into the solvent, and after stirring we now have a solution. So what are we going to do with the solution? We are now going to get our inner glass tube and reassemble it into the apparatus as it was before, and continue stirring until we record another temperature to which it will start to freeze. So the apparatus, we are going to say that the apparatus or the inner glass tube is then reassembled back, and the mixture is continuously stirred, and the mixture is stirred until again a steady or constant temperature, at which the solution freezes is observed and recorded. As what? As the freezing point of the solution. We can now call this one T degrees Celsius. So now, this is all that we need from this experiment. We now know the mass of the solvent, we know the mass of the solute that was added, we now know the freezing point of the solvent, we now know the freezing point of the solution, and we are sure we know the Kf of the solvent. Now, having all those results from this experiment, we can carry out treatment of results. Now, in all experiments that we are asked in physical chemistry, we are required to draw the setup of the apparatus that is used. We are required to describe the procedure, and the procedure doesn't end until we have treated the results. So what we are going to do is now treatment of results. We are now going to look at treatment of results. See, how do we then determine the molecular mass from these results that we have? We can now look at the results we have. Treatment of results, what do we have? We have mass mass of the solvent. Mass of the solvent is given as A grams. We now have the cryoscopic constant. Cryoscopic constant. The cryoscopic constant of the solvent is given as Kf in degrees Celsius per mole per kilogram. Okay, we now know the mass. Actually, we know the, I can talk about mass, okay? Mass of non-volatile solute being equal to mass of non-volatile solute is B grams, but also we know the freezing point of solvent. Freezing point of the solvent is equal to T naught degrees Celsius. And then we know also the freezing point of the solution. Freezing point of the solution, which is T degrees Celsius. So after having all these results, we can now treat the results properly using the knowledge that we developed in the mathematical calculations that we had in the previous lessons. So what are we going to do here? We are now, if this Kf is in per kilogram, then we are going to change this to this mass into 1,000 grams of the solvent. So we can say that A grams of the solvent dissolve B grams of the solute. So the question is, what about 1,000 grams of the solvent? Will dissolve how much? We shall have B times 1,000 grams over A. So this mass now is in 1,000 grams of the solvent. So what did we say? Once we have the mass in 1,000 grams of the solvent, we can now relate with Kf. Remember our dt is going to be T naught minus T, this one in degrees Celsius. And this dt is caused by this mass. So we can now say that dt is depression caused by B times 1,000 over A grams. So the question is, what about Kf? Kf is depression caused by 1 mole, which is molecular mass, and will be given by, so we cross multiply. So molecular mass is equal to B times 1,000 times this Kf over dt times A. And so by getting this expression, you have clearly shown how you can determine molecular mass in our experiment. So you've seen that it's until you are here that you have been able to describe how you can determine molecular mass using this method in the laboratory. In the next lesson, we shall see how else could we treat the results. If not this way, we could treat the results by graphical methods. So we shall see the graphical methods used to treat results. See you in lesson 7.